Lesson 93, Products of Rational Expressions. This is a two-parter. We're going to deal with the products of rational expressions first. So let's say we were given a multiplication problem of two fractions. And that problem was 4y over 5x times 3xa over y. Now, the first thing that we're tempted to do is just multiply straight across, which is fine, but sometimes we get a faster, easier answer if we take the time to factor first. So if we look at each of these, when we factor, we want to take something out of the top and something out of the bottom when it comes to fractions, because then that means it's equally removed from both the numerator and the denominator. So if we see something that is a factor on the top as well as the bottom, we can just take it out of the equation, and it's the same as if this division line were an equal sign. Whatever you do on the top, you have to do on the bottom. So in this problem, I see right away, let me get my red pen here. If it'll give me my red pen, there we go. We see that we have a y in the top, and it didn't take the red. A y in the top and a y in the bottom, so we can go ahead and get rid of that. Now we also have an x in the top and an x in the bottom, and you know that this is just multiplication between these because the variable just means times whatever coefficient it's with. So we can factor all of those out and then just multiply whatever's left. So what we end up with is 4 times 3a, which is 12a, and whenever you remove everything from underneath a fraction, you're left with a 1. You always replace it with a 1 because whatever is on top is going to be a whole number, and that's how you make a whole number into a fraction, is by putting 1 under it, correct? So 5 times 1 is 5. So that would be the answer to this problem. We factored out everything we could factor out. We simplified it first and then did the multiplication. Usually we multiply and then simplify. This time we're doing it just a little bit differently by simplifying first. And what that does for us is it keeps us from having to deal with these huge numbers that we then have to turn around and factor out and reduce. It's like we're reducing on the front end. And that's a good thing because it saves us from struggling with large numbers and large values, and it also saves us time. Okay. All right, so let's look at, here is a problem for us, 93.1. All right, we are told to simplify this problem. We have x squared minus 25 over x squared minus 7x. My pen is jumping around today. Times x squared plus 3x over x squared minus 2x minus 15. All right, so first let's look at these binomials and this trinomial. Is there anything that we can do to simplify them on the front end? Well, this is a perfect square. So we can factor it as a perfect square. We can actually say x plus 5 times x minus 5. Okay, so now we have that factor. So it's simplified. And if we look below, we have x in both of these, so we can say x times x minus 7. So that's in its simplest form. Now we can move over here and see what this is. And we can say, oh, it's the same thing as down here. We can take x out. X times x plus 3. And then we have a trinomial down here that can be factored out. And it can be factored into, let's see, we have x, because we have x squared, we do x and x. And we have negative 15 that has to give us a negative 2. Well, the factors of negative 15 are -5 and +3. If they're combined, that gives us a -2. So -5, +3. Well, do you see what I see? I see an x minus 5 here. Let me switch to my red pen. We have an x minus 5 here and an x minus 5 here. We have an x here and an x here. We have an x plus 3 here and an x plus 3 here. So what we have left is x plus 5 over x minus 7. Isn't that easy? That is so much easier than multiplying all of these together and then having to try to reduce them later. And we know we can't reduce anything here. This is our final answer because we factored everything out here. Right? All right, so let's do 93.2. So we have 93.2. We have x squared plus x minus 6 over x squared minus 4x minus 21 times x squared minus 8x plus 7. And that's all over x squared minus x minus 2. All right, so let's get to factoring. So this first one, we can set this up. And I see the x, and then I see that we have a negative here and a positive here. So we need factors of -6. That leaves a positive 1. So positive 3 times a -2 gives us a -6. So we need to have a positive 3 and a -2. Okay? Now, let's do this one on the bottom. We have x and we have x. And we have a -21, and the result needs to be a -4. We know that 7 times 3 is 21, and 7, if we take 3 from 7, we have 4 left over, and because it's a -4, the 7 has to be negative, and the 3 has to be positive, okay? Times, let's set up our parentheses. We'll go ahead and set up the bottom too while we're at it. All right, so we have x squared, so x times x. We have a positive 7, but a -8. Well, a negative times a negative is a positive. So if we have -7 times -1, combined, that is a -8. So that's what our answer is, -7, -1. Or those are what our factors are, not our answer. Now, on the bottom, we have x times x, because it's an x squared. And we have a -2, and we have a -1. So we need a positive and a negative factor. So that will combine, will give us a -1. So if we say positive 1 times -2, that gives us a -2. And when we combine a positive 1 and a -2, we are left with a -1. So it's going to be -2 and a positive 1. And that's going to give us the answer we want. Now we can factor out, we can cancel. So I see an x plus 3 and an x plus 3. And I see an x minus 2 and an x minus 2. And I see an x minus 7 and an x minus 7. So all that we have left, the answer is x minus 1 over x plus 1. Cool, huh? All right. There we are. That is it for the first part of lesson 93. Now let's move on to the second part, which is quotients of rational expressions. So it's the same thing, only in division. Okay, so let's clear this. 93.3. So we are given x squared minus 2x over x squared plus 2x minus 8. divided by x squared plus 5x over x squared plus 7x plus 12. So first, we are going to factor this perfect square. Actually, it's not a perfect square. I'm sorry, that's my mistake. We are going to factor this, though, by removing x. So we have x times x minus 2. And we have a trinomial we're going to turn into this quadratic here. Or I'm sorry, this binomial, pair of binomials that we're going to multiply. And that is going to be x and x. And we have negative 8 that needs to equal a positive 2. So that tells me we have positive 4 and negative 2, which makes negative 8, but would leave a positive 2 behind. All right, now, this is division. So we're going to do keep it, change it, flip it. So we kept this just like it was. We're going to change this, and then we're going to flip this. So we are going to factor the top on the bottom. Okay? So we have the same thing here that we had here. So we're just going to take x out and put x plus 5. Okay? Awesome. Now we're going to take the bottom and factor it to the top. And we have 2 pairs of parentheses here to fill. So it's x and x because of x squared. Now we need to have the factors of 12. That would give us a positive 7. And that's going to be 4 and 3. So positive 4 and positive 3. All right, so now we can cancel. We have everything factored. So I see x plus 4. I see x. I see x minus 2. And that's all I see. So we have our answer, x plus 3 over x plus 5. And remember, we can't factor out the x's because they're part of an operation. So this is an entire value by itself. If this was x times 3 and x times 5, then yes, we could take it out. But it's not. This is a value unto itself. Okay? The whole thing. Very good. So keep it, change it, flip it applies always for this division stuff when you have these fractions. All right, let's move on to 93.4 because I think you guys are getting the hang of it. And then this is the last one for lesson 93. So x squared minus x minus 6 over x squared minus 3x minus 10 divided by, and listen, you might see this written a different way. I'm going to go ahead and do it for you. You might see it written like this. It's the same thing. So we're going to try that. All right, so we have x squared plus 5x plus 4 over x squared minus x minus 20. So when we see it like this, we know that this middle one is just your divided symbol, right? This fraction divided by this fraction. And all you have to do is rewrite it as keep it, change it, flip it. So let's do that. So we're going to keep it, change it, flip it, and then we can get rid of all of this down here. And then now we know what to do. We just factor it out and move on. So we're going to do this one. It's going to be x, and that is going to be negative 3, positive 2, because we have a negative 1 remaining. All right, this one is going to be x, and that's going to be negative 5 times positive 2, so negative 5, positive 2, because we have a negative 3 remaining, times, and we already flipped it, so we can put our parentheses in place right here, and we can fill x, and we need negative 20, so that's going to be a negative 5 and a positive 4. That leaves behind a negative 1 when these two factors are combined. So on the bottom, we have x times x, and we have a positive 4 with a positive 5. Well, that's easy. Positive 4 times positive 1, when combined, give us a positive 5. All right, now we can cancel. So we have an x plus 2 and an x plus 2. We have an x minus 5 and an x minus 5. We have an x plus 4 and an x plus 4. And that leaves us x minus 3 over x plus 1. Very good. Y'all are doing awesome. I just know y'all are going to just knock this out of the ballpark. That's all we have for lesson 93. That was pretty quick. I hope you guys get the hang of it real quick and see that the division problems, you just keep it, change it, flip it. Even though they're longer, factor them out, just like we've been doing with the trinomials. Just factor your trinomial, and then you can cancel, and it's so much faster than having to deal with those big, long numbers. We don't want to do that. That takes up too much time, and it makes our brains hurt. I know it makes my brain hurt. So let's do it the easy way, which is what you just saw on the screen. All right, rework these if you need to, and I will see you in lesson 94.